So if you look at the tilt of the Earth is always tilted like this, but sometimes it's on the other side of the sun. So up here where we live in the northern hemisphere, if I move the Earth over here, then we'd be tilting toward the sun. But on this side, we're tilting away. And 5:02 p.m. on the 21st is when we'll have maximum tilt away. And one thing you can see, if you look at the equator and everything north of that, most of this is darkness. In the southern hemisphere, most of it's light. So as we rotate around, we spin around every day like this. We'll spend, well, here's where we are. That must be Florida, and this is Mexico. So Vermont, somewhere around here. We'll be in the light here, and then we'll go into the darkness, and we'll spend all this time in the darkness. And then on the other side, we'll be in the darkness. And then somewhere on the other side, we'll come out in the light. And then we'll be in the light until there. So we're not in the light for very long. And any place north of the Arctic Circle doesn't have any sunlight at all. If you went around and around there, you would never go into the sunlight. The North Pole actually has 6 months of night, and then 6 months of daytime. So right now, well, not right now, but on the 21st, anywhere south of the Antarctic Circle can never enter the darkness. So they'll have 24 hours of daylight. And the very South Pole is going to have 6 months of daylight, followed by 6 months of darkness. Has anybody seen Happy Feet in the movie? They're not quite at the South Pole, but they're pretty close. So they have a long period of darkness. So let's see. Let me duplicate this and go back to my. Actually, I guess I don't really need to duplicate it. Still got the page open. Why is it significant? We kind of answered all those, but I want to focus on this picture. The picture doesn't show it, but you can understand the seasons with this picture. I guess that top one's not labeled. Again, we have my picture on here. So can you find where we are right now? Just looking at the dates. See if you can locate our present position. We should be somewhere around right here. And we're going around in this elliptical path counterclockwise from this position. So we'll be here later on. This will be the first day of winter. And this was the equinox. This was when day and night were equal. That was on the 23rd. So between then and there, that's fall right there. And then on the shortest day of the year, winter begins. And then the days actually get longer until the spring equinox, and then spring's going to begin. So the lengths of the days in fall are just as short as they are in winter. Actually, on the first day of the winter, the days start getting longer. But it still keeps getting colder because it takes the Earth a long time to cool off. And remember the weird thing, I think I've told you this. Right here, January 3rd, perihelion. Does anybody know what's that showing us? What's significant there? Perihelion and aphelion are opposites. In what way? They're the times we're closest to and farthest from the sun. So first day of winter is right here. It's going to keep getting colder and colder and colder until somewhere around the middle of winter. But we're actually closest to the sun there. And then we're going to be farthest from the sun. So this is when spring begins. This is the first day of summer. Sometime right around the middle of summer, we're farthest from the sun. So again, it's not the distance from us to the sun that's important. It's the angle of that tilt. So anyway, we've got today's the 3rd. So we've got 18 days left. And once you start to get close to the solstices, the amount of daylight kind of goes like this. It goes down, and then it goes back up. It's not like this. So once you get close to the solstices, the days really aren't going to get much shorter from here on out. And then after the solstice, they're not going to start getting much longer for a while. They change the most right around here and right around there. All right. So that's not what we're doing right now, but that's still earth sciencey. Solely, still just you, huh? All right, hopefully other people will be watching the video. So, Google Meet. It says this will be a quick one, so I'll make this quick. There are 3 versions of the test, which I told you about yesterday. I've got them right here. This is version 1, which I've changed a tiny bit. Version 1 doesn't have any kind of support material with it. It's just this. You go get yourself 3 sheets of paper and you draw everything it describes on here. And whatever your score is, you get that score and maybe some bonus points. So the change, I don't know if you can see it up there, but see those little numbers? I decided that in the beginning, when I was telling you what features to draw, I'll give you an order that will work. So you don't have to figure out which order to put them in. Like for example, you could just use this one. This is the answer key for the easy version. Or no, this isn't the answer key. Let me go, I'll show you the answer key. So this, I took my easy version of the test last night where all you really have to do is label stuff. And starting from the left, number 1 is continent-continent convergent plate boundary. And then the next one's continent-continent divergent, and then ocean-continent convergent, or actually I probably should have called this continent-ocean convergent because of the order, but it doesn't matter. Then ocean-ocean divergent, then ocean hotspot, then ocean-ocean convergent. So oh, what the heck? Yes?
Can you put that on Google Classroom?
Yeah. Yeah.
When I took a look yesterday, I don't know if I didn't see it, but the only one that you had was like only the bottom one.
Oh, on Google Classroom?
Yeah.
Yeah, I hadn't put any of those there because I didn't really know which ones you'd want to do. So just until I do that, because it might take me a while to remember to do that. In fact, if you can email me to remind me, that would help. But until then, if you just go to my website, you know how to get to my website? Oh, so just do MR Stapleton. And you don't have to even do .com, but I think if you just do MR Stapleton, you can find it. And then click on Earth Science or click on ESS. And that takes you to here. So all the links are there. Just about every link that I ever give you that's on Google Classroom is on here, and more stuff too. Because it's a lot easier for me to add links here than in Google Classroom. So back to what I was just saying. Let me get my picture up again. So these little numbers, yeah, you can see little numbers written in there. Those are telling you, if you do them in this order, it's going to work out. So this is the hard version. You have to do all this stuff, just draw it all on your own. You can get bonus points for this. I think up here, +2 bonus points for rearranging your plate boundaries in a way that's different from the solutions below, and also different from my other example in class. So this was my example in class that I started to do. And this is pretty much the same as the solutions that I just showed you the links to, except if you examine it, you'll notice that the hot spot is on some crust that's going to the left. So the biggest volcano is here, and they get smaller going to the left. And I think on the other version that I just showed you, the hot spot was over here. It was positioned on this ocean crust. So anyway, if you come up with a different order of these things that's different from this and different from the other example that I just showed you, then I'll give you, and you do that 100% version, a hard one, then you get 102. So you can get above 100 on this test. All right, this is the medium one. So I'll just show it to you again real quick. Here's a description. And then you can see you get 3 sheets of paper like this that you have to put together, and they don't have it doesn't have anything shaded in, but it has all the stuff started, so you don't have to draw the basic shapes of things. And if you put it all together, it looks kind of like that. So you can get 95% of the points this way. Whatever your score is on this, I'm going to multiply it by 0.95, and that's going to be your score. So if you get everything right, you get a 95. Can't get 100 if you do this. And then there's the easiest option, where I really give you a lot of stuff. Go back to this. This is what you get. You get everything shaded in, everything is drawn. All you have to do is label the things. But even if you get everything right here, you only get 80%. So your score is going to be an 80 for 100% of this, which, when you think about it, is a little bit harsh. But you've got choices. You could try the hardest thing. If you get 80% of the hardest thing, that's still as good a score as 100% of this one. And here's a solution that I just did last night. So for this sheet that I've got right here, this describes everything you have to do, and you can see there's not as much. The first part is basically tape your paper together and then label these things. So this is the part where I ask if you have any questions, and nobody ever has any questions, but I still keep asking anyway. Does anybody have any questions? All right, so what I'm going to want you to do, so Tommy and Soli, if you can print these out, you can choose the version that you want to choose, or that you want to try, and then your task is just to do that, to try it, and then to check your answers. So you can check your answers with these two links on my website. Right here it says, here's the medium version solution. Here's the easier version solution. Even if you do the hardest version, you could look at one of these two solutions, and they're going to be, look at the medium solution if you do the hardest option. So your goal is just to practice this, and then you're going to actually have your test on Monday. So Monday, you tell me which one you want. I'll give it to you, and then you do it. These guys in here are going to be doing something a little different. Any questions from Tommy or Soli? All right, Tommy and Soli, I'll check in with me tomorrow. And that's it. I'm going to end the call unless you have questions. All right, bye. I guess they're there. So for all of you, let me get rid of some tabs. We've got a quiz retake that we discussed taking right after break, and then after break changed our minds and decided to take it today, and it's right here. And there are two parts to it. There's the easy part where you just have to identify plate boundaries like convergent, ocean, continent, ocean, that kind of thing. And then there's the part where you have to identify places on the Earth. And some of you probably haven't studied it all. Some of you probably have, and you're ready to do it. So if you're ready, I'm probably going to disappoint you a little bit, because I want to do a little bit of review first. And you'll think, why did I even study? But it won't hurt you. So this was the slideshow I made a while back, and I'll just go through some of the examples of different types of boundaries. So the ocean-continent convergent. Here's what it looks like from the top. You can see South America there, and then there's this Nazca plate going underneath South America. From a cross section, here's the ocean plate going underneath the continent. It's making the Andes Mountains. So if you can remember South America, Andes Mountains, either of those, if you can remember that it's either of those, then you've got it. Because it says on the quiz, Andes Mountains, South America. That's ocean-continent convergent. And there are a bunch of llamas here on these volcanoes, and alpacas and things like that. So the next one, continent-continent convergent, that's when the example I've given you, India is crashing into Eurasia. And both of these are continental crests, so they're not dense enough to sink, so they just smash into one another. Neither one can go down underneath the other one, so they just smash and get bigger on their ends. So it looks like that from the top, right here, These would just be tall mountains. And then from the side, it kind of looks like this. Continental crust is just, it's going up and it's going down, but nothing's really subducting. So, really tall mountains, like Mount Everest. On here, I think the choice says Himalayas, in parentheses, Mount Everest. That's where two continents hit each other. The next kind of plate boundary, ocean-ocean divergent. And the best example of that's the Mid-Atlantic Ridge, where this ocean and that ocean splitting apart. So if you see an ocean doing this, that's like the Mid-Atlantic Ridge. There really aren't a lot of other good examples of spreading ridges like that. And maybe this is one. We could look on Google Earth. Here's what it looks like, kind of like an alligator that's half buried under the ocean. The transform boundary, this is not, this is actually still the Mid-Atlantic Ridge, but it just shows how even along the place where you have spreading like this, if you have a jagged line, then this part becomes transformed because these are sliding across one another. But that's not the best example of a transform fault. So ocean-ocean convergent. The example I gave you was Japan. This ocean plate and this ocean plate are colliding. This one's going under that one and making the volcanoes. So Japan, if you can remember, Japan's an island and it's a volcanic island. It's not a hot spot. The only other kind of volcanoes we talked about are when there's subduction. So it looks like this from the side. Oops, sorry. An ocean plate going underneath an ocean plate, making these islands. Here's another picture of it. This is the Pacific Ocean. This is the Sea of Japan. This is Japan. Next example, a hot spot. There's the mantle plume coming up, and then these are all the old volcanoes that used to be right there over the mantle plume. So Hawaii is the hot spot. Most people can remember that one. The one that people have a lot of trouble with is the continent-continent divergent. That means a continent is splitting apart. What continent is splitting apart? Jace, Africa. So here's where Africa is doing it. There's a little picture of Africa. It's this part right here that's going this way, and the other part's going that way. And all this dark stuff's coming up in between. Here it's made a couple of really small shield volcanoes that are going to get split apart. They're never going to get too big like the ones in Hawaii. Here's another example of rifting. And now, transform. The best example of a transform fault is in California. Part of California is going this way, and part of California is going that way. Here's a better picture of it, the San Andreas Fault. Continent, transform. And there's a good picture of this went this way, that went that way. Now, it felt like it was kind of nice to look at these on Google Maps. You can see these. One of the easiest, guess what the easiest feature of all this stuff is? So if I were to show you this. So we've got tall mountains, we've got a rift valley, we've got composite cone volcanoes, we've got a trench, we've got a mid-ocean ridge, we've got shield cone volcanoes. Guess which one of these shows up the best on Google Maps? What feature do you think you can see the easiest? I'll start in Vermont. Any guesses? Well, you'll notice pretty soon. You can do this in any order. I'm going to go to satellite view and then zoom out. I think I'm zooming out. And I'm going to go down to South America because we'll see it first there. All right. So here's our Ocean continent convergent plate boundary. What's something that really stands out there? What? The water, is that what you said? Yeah, so this really dark blue right here, what is that? Is that shallow water or deep water? Deep water. So what does that correspond to on here? Yeah, and it's this trench. So what we're seeing is trenches. When you have ocean continent convergent, you'll have volcanoes on the land, and then the trench is right between the land and the ocean. So this is the trench, and then the volcanoes are all along here in these mountains. So that's ocean continent convergent. Let me search for San Andreas Fault. And it's zoomed in so much, it looks like this. I'll zoom out a little bit. You can see it. So this left side is going to the northwest, and the right side's going to the southeast. We're going to lose sight of it as we go higher. Now it starts to look like California, but you can't really see this like you can see those trenches. I'm going to go to Japan. What are you going to see in Japan? What kind of a plate boundary is? But I'm actually going to stop before I get to Japan, because I see something interesting here. See this and this, where it says Midway Atoll? Anybody know what these are? What causes all these these are extinct volcanoes in a line like this, out in the middle of the ocean, not near any kind of a plate boundary. If I keep tracing them down, I eventually get to Hawaii. So what's this one? I didn't mean to go to this one next. This is the ocean hotspot. And the hotspot itself is right there. It's actually probably right here. So the crust is moving up and to the left, going like this. And somewhere down here is where it's really hot. So there's going to be a new island that starts to get built right here. There's still vents where lava flows out here. Not really so much there or there or there anymore. Those are just older islands that are starting to cool off and shrink and get eroded. And you can see the path that the ocean floor has taken. It's like a sewing machine or a bandsaw. As you push the fabric through, you push the wood through, you get this trail. And the stitching and the cutting is happening right here, but here's where it's all been. At some point, I think it was about 60 million years ago, this took a turn. If you follow this line to here, then it turns and goes north. So that crust used to be going a different direction, and it's changed directions. Just sort of fades out, and it probably used to go farther up, but what's happening to this crust right up here? What kind of a plate boundary is this? Let's just focus on this part, because there are a couple of them. What's the dark blue? That's a trench, and if there's a trench, and then over here there are these mountains, guess what these mountains are? These are volcanoes. So which plate's diving under the other one? Is it the Bering Sea plate, or is it the Pacific plate? Which one's diving under? It's the Pacific. So this is going under the Bering Sea, and then it melts and comes up and makes these volcanoes. So this probably went on, but it's just diving under here, and it's getting recycled back inside the earth. And same thing's kind of happening over here. This is going under over here, and you can see the volcanoes coming up. And that takes us to Japan. So instead of Japan, I could have used the Aleutian Islands of Alaska as the same example here. What kind of a plate boundary is Japan or the Aleutian Islands? What are the two plates involved in, like, Sea of Japan and North Pacific Ocean? What kind of plates are they? Ocean or continent? They're ocean. And since there's this trench here, they're coming together, so they're convergent. All right, there's another. I want to go to the continent-continent convergent boundary. And I'm going to choose somebody to tell me where I need to go for that. Jace, where do I need to go for continent-continent convergent? South America? I'll give you a hint. It's actually pretty close to where I am here. If I center on Japan, we might actually start to be able to see it. Yeah, you can kind of see it.
Oh yeah, isn't that India?
Yeah. So if I keep going to right here, this is it. This is the plate boundary. And India and Eurasia are crashing into one another. India is going this way. Eurasia is going this way, and that's making the Himalayas there. All right, I'm going to pick somebody else. And the question I have for you is, what's the continent that's splitting apart? Megan, what continent's splitting apart? I'll name some continents. North America, South America, Europe, Asia, Africa, Australia, I guess, is the continent. Antarctica. Which one's like breaking up? Let me pick somebody else. Mandy. Elijah.
Africa. And are those mountains always getting bigger?
Yeah. Well, let's look into that. So the thing about it is they get bigger, that's more weight, which is going to make it sink into the mantle. So I don't know if they're getting bigger fast enough to actually keep growing, or I'm sure Himalaya is growing or shrinking. Himalayas continue to rise more than 1 centimeter a year, growth rate of 10 kilometers in a million years. If that's so, why aren't the Himalayas even higher? Scientists believe the Eurasian plate may now be stretching out rather than thrusting up. And such stretching would result in some subsidence due to gravity. So apparently they are growing,
Not very fast.
but yeah, well, none of this is fast. It's all about as fast as your fingernails grow. So for a mountain, that's pretty fast. But I guess what they're saying is at the same time that this is smashing into that and this is smashing into that, this is actually kind of stretching out, which is making it go down a little bit. Things are complicated. All right, so I'm going to get to Africa. And this is something you can't really see very well. There you can see there's kind of a mess going on right here. Let me Google Africa Rift Valley. The Great Rift Valley. One thing that is kind of cool about the Rift Valley, Djibouti. I've always liked that name. It's a funny name. Let me try that again. Great Rift Valley. This is a hard one to see. It really doesn't look like much, does it? So I guess this must be part of it. It's kind of a mess of cracks. When I was looking at this before, trying to see if I could find something that I could show you that really looks like it's breaking apart, one thing I did see was these dark areas. Oh, like this. And at first, what do you think those are? What? Yeah, at first I thought they were lakes because I was looking from far out, but then as I got in closer, it actually looks like this is just really dark rock. This looks like a lava flow. So as the crack is opening up, or little cracks are opening up here and there, ooh, I can go to 3D. How do I, oh, there we go. As the crack is opening up, this lava is flowing out and just spreading across the surface. This is really dark stuff, and it does look like there are some volcanoes that are forming here. But those will all go away as it splits apart. Those volcanoes are just going to kind of fall into the crack, and those are going to become ocean crust. But you can definitely see the dark stuff coming up. All right, I think that's all of the plate boundaries. Just a quick review. San Andreas Fault, continent transformed. San Andreas Fault's just the main thing they have in California to worry about, at least Southern California, is earthquakes. They don't have big tall volcanoes right around Los Angeles. In Africa, that's the one that's splitting apart. Two continental plates splitting apart. The hot spot is Hawaii. Japan is ocean convergent. It's got a trench by it. It's got volcanoes. There's ocean on either side. The difference between the volcanoes in Japan and the volcanoes in Hawaii are the Japanese ones are steeper because they've got all the felsic sediment, this sediment from the ocean crust on there. They also get water mixed in, which makes gas. There's a lot of steam that makes them explosive. But they're steeper. They're not rounded like the ones in Hawaii, and they're all the same size. Whereas the Hawaiian ones, there's a big one, smaller one, smaller one, smaller one, smaller one as they get older. So if you see a bunch of volcanoes getting smaller and smaller, that's a hot spot, not a convergent boundary. Next one, mid-ocean ridge. That's ocean divergent. Ocean splitting apart is the mid-Atlantic ridge. Continent convergent. That's India hitting Asia, Mount Everest. And then finally, ocean continent convergent. That's South America and the Pacific Ocean. All right, I'm going to hopefully